All right, so let's just first start talking about what it is, what the concept of a zero is, right? So when we hear that word, a zero of a polynomial function, it's basically the x value where the graph crosses the x-axis, right? So if I have the x-axis, the y-axis, and if I have a graph that looks like that, all of the points where the graph crosses the x-axis are zeros of the function. Okay. A zero can also be referred to as a solution, an x-intercept, or a root. Right, so all four of those mean the same thing. Zero here, zero, solution, x-intercept, root. Those all mean the same thing. All four of those mean the same thing. All right, let's do a few vocabulary. Evaluating a function at a given point. So there are two methods to find the value of a function at a given point. And these are direct substitution and synthetic substitution. Okay. Direct substitution is exactly what it sounds like. You just directly put a value into a function and get the outcome, right? So here we're going to do these using direct substitution. Okay. All right, so let's first find f of 2. We're given this for f of x, right? And I want to find f of 2. So look at that. We started out with f of x. Now we have f of 2. So basically what happens is the x got replaced by a 2, right? That means in your function, every time you see an x, you have to just replace it with a 2. So that's 2 times 2 squared plus 9 times 2 minus 35, right? So how much is that? That's 2 times 4 plus 18 minus 35. So that's 8 plus 18, 26 minus 35. How much will that be? Any ideas? -9, right? So f of 2 is -9. All right. Well, what does that mean? Let's think about what that means. That means when x is 2, y is -9. That's what that means. So when x is 2, y is -9 right there. Okay. All right. Let's take a look at this other one. Let's do this one. Here again, wherever we see an x, we're going to put a -7. So 2 times -7 squared. Now, especially when I have a negative number, I use parentheses. Okay. All right. So 2 times -7 squared plus 9 times -7 minus 35. All right, so this is 2 times what? How much is that? Negative or positive? 49. Positive 49. Okay, minus 9 times 7 minus 35. All right, I want you to put this in your calculator and let me know what you get for f of -7. F of -7 is equal to 0. So what does that mean? When x is -7, y is equal to 0. So let's take a look at what that looks like on here. When x is -7, y is equal to 0, right? So what does that mean? What do you know about that point? It's a what of the function? It's a 0 of the function, right? So here it says, now the next question says, are any of these zeros of the function? So yes, x equals negative 7 is a 0, right? Why? Because, yeah, f of negative 7 equals 0. This means f of x crosses x-axis at x equals negative 7. All right, so we learned a couple things then about zeros. A zero is an x-intercept. It's where the graph crosses the x-axis. And the y value then at this point is 0. That's why it's called 0. Okay? All right, so we did this using synthetic substitution. And you can see, especially when the numbers get pretty big, you know, that this method, it's pretty like tedious, right? And you're working with large numbers and you're squaring and blah, blah, blah. It's kind of, it's not that easy to work through. Well, let's take a look at synthetic substitution. What does that word synthetic mean? Synthetic, what, like in just random non-math life, huh? It's not real, it's man-made, right? Synthetic means like man-made. So that's what synthetic substitution is. It's not the real thing, but it's good enough, okay? All right, so given f of x, again, it's the same exact function. We're going to find f of 2 and f of negative 7, same exact values, but in another way. All right, so synthetic substitution, here's how you do it. You make a chart. Yeah, it's just like synthetic division. Yes, as do I. Here, you put the coefficients. You put the coefficients of the function with the sign. So 2, 9, negative 35. Now, one thing you have to make sure is check that all exponents are there, which means what's the highest exponent in that function? It's a 2. So all the exponents starting with a 2 and going down to 0 should show up. That means 2, 1, 0. So I have an exponent of 2, 1, 0. I'm good. And these coefficients should be in the same order as that. All right. Now, outside, I put this number 2. Okay? Now, here's how we're going to do it. This first number comes down for free. Okay? Just comes down. Now, whatever makes it down to this bottom row gets multiplied by the number out here. So, 2 times 2, that gives you a 4. You add vertically 13. You add. Yeah. You add the long division, the non-synthetic long division. Yeah. And now, whatever comes down here gets multiplied by 2, 26. You add this way, you get negative 9. Is that what we got before? Oh my God, that's so what we got before. So now look, you might think I'm just playing around with these arrows here, but I do my arrows like this on purpose. When I put my arrows diagonally like this, I mean it to say times, multiply. And when I put it vertically like this, I mean to say plus. If you think of it that way, then you won't get confused whether you're supposed to add or subtract. Okay? So you're adding and then multiplying. Okay? All right, so negative 9. It's okay, so when you're doing synthetic substitution, this value here, that is f of negative 2. Okay? Right? Negative 9, that's what we got here, negative 9. All right, so let's do that next one. Huh? Oh, I'm sorry, f of positive 2. So let's do that next one. In here, we're going to put, again, the same coefficients. What goes out here on the left side? Negative 7. All right, same exact way. The first one comes down for free. All right, and now whatever makes it down here, it gets multiplied by negative 7, so you get negative 14. You add this way. How much?
5. Right. Yeah.
5 or negative 5?
Negative 5.
Negative 5. Okay? You multiply, you get positive 35. You add, you get 0. Again, that last number there is your f of negative 7. So f of negative 7 is equal to 0. Right? So how can we tell if any of these are zeros? Basically, f of negative 7 is equal to 0. Okay? Questions? So, division, direct substitution up there, synthetic substitution down here. Okay? Yeah, so this is just like synthetic division. Remember when you did polynomial long division and then you do this synthetic division? So I call this, it's like the tofurkey of division, right? It's like, it's almost like it's okay, but it's not the real thing, right? And that's what it is. It's okay, but it's not the real thing. Okay. So let's talk about polynomial functions, right? We throw this word around all the time, polynomial functions. Sometimes we forget what it is that we're referring to. Okay, a polynomial function is something that looks like this f of x, all right? Basically, you've got coefficients, you've got your variable x, and those x's have exponents that are integers from 0 and up. Okay, so you basically have x to the power of an integer, x to the power of 2, x to the power of 1, x to the power of 0, x to the power of 5. That's what a polynomial function is. Okay, now let's talk about what the degree of the function is. Right? Does anybody remember what the degree of a function is? The highest exponent, right? So let's write that down. So degree is highest exponent of f of x. Okay, so if a function has a degree of n, okay, whatever the degree is, it can have at most n real zeros. Okay, so if you have f of x equal to, let's say, 2x to the 4 plus x squared plus 5, what's the degree? 4. This means this function can have at most 4 real zeros. Okay? Now, those zeros could either be rational or irrational. So for example, when you solve the function, like look at this one. How many zeros can this have? 2. Okay? In this case, the zeros are -3 and 2/3. And if you remember, this is a rational number. Both of these are rational numbers. How do you know? Because it's either a whole number or it's a repeating decimal, like 0.6667. Okay, look at this one. 2 zeros. What are the, 2 possible zeros. What are the zeros? Plus or minus √5. How much is √5? If you put it on your calculator, what do you get for √5?
Something long.
It's something long. Okay, so does it have a pattern? No. Does it end? No. It ends in your calculator, but in reality, it never ends. It goes on forever and ever and ever and ever and ever. So this is an irrational number. Okay? All right. Well, it turns out we can narrow down the rational zeros. Okay? So look at this function. How many zeros did we say it has? 4. All right. So look, here's one way you could figure out the zeros of this. How many numbers are there in the world? How many like rational numbers like this? How many? Infinite. What you could do is you could randomly choose a number, plug it in here, and see if it's going to be a 0 of this. And you could do that again for all infinite numbers of numbers. Now that's a silly little way of doing it, right? Or what we could do is we could narrow it down from an infinity amount to a very small amount. And the way we do it is this theorem, right? what we're going to do now is we're going to list all the possible rational zeros. All right, so let's do that here. So basically what we're going to do is we're going to say, okay, what numbers could possibly be a zero of that function? All right, I know you've done this before. Remember P over Q from algebra 2? Okay. So look at this polynomial. What we have to do is find values of P. Never mind why it's P, it's just P. What we do is we find all the factors of the constant term 4. So this number, all the factors of 4. So what are the factors of 4? How do you multiply to get 4? You could do 1 times 4, right? Or you could do -1 and -4. Yeah? Which means how do you write it? You could do plus or minus 1, plus or minus 4. How else could you get a 4? 2 times 2, or -2 times -2. So you could do plus or minus 2. All right, so those are the factors of 4. Then, to find the values of Q, you need to find the factors of the leading coefficient 2. So this number gives you P. This number gives you Q. Right? So what are the factors of 2? 1 and 2, but you put plus or minus in front of them. Okay, now we're going to divide each of the P's by each of the Q's. So here's how you do that. First, you take this one, right, and divide by 1. Okay, so it's going to be plus or minus 1 over 1. Then you take this and divide by 2. So it'll be plus or minus 1 over 2. Okay, now you take the next number, you divide it by the first Q and the second Q. So it's going to be plus or minus 2 over 1, 2 over 2. All right? Do you guys see what I'm doing? Huh? So I'm going to take the 4, divide 4 by 1, and divide 4 by 2. Now, when you do that, you have to simplify, okay? Here, this gives me a 1. This gives me a half. The next one gives me a 2. Now, what does this give me? 1. Did I already write 1? I don't have to repeat it. This gives me a 4. What about the last one? Gives me a 2, which I already have, so this is it. I'm done. All right? So these numbers form a list of all possible rational zeros of the function x, f of x. Let's write it in, what do you call it? More concise form. You don't have to write the plus or minus all the time. I'll show you how to abbreviate it. I'm okay with if you just do plus or minus and then do 1, 1/2, 2, and 4. Okay? How many numbers are in here, in this list? 8, right? Because there's 1, 1/2, 2, and 4, and then the negatives of them. -1, -1/2, -2, -4. So there are 8 total. Okay, what have we found? How many zeros is this function going to have? 3 at the most, right? If those zeros are rational zeros, they have to be off of this list. For example, is x equals 5 on this list? No, it can't be a 0 of this. So remember how I was saying we could either take like the infinite number of numbers and try them one by one? That's silly. Well, now we have 8 possibilities. One of these 8 could be a 0 of this. So not -3, let's say. Not +10. Just one of these 8. Okay? All right, so let's do that here. Let's list the possible zeros of this function. All right. So Okay, let's find all the zeros here. Can we determine the P over Q? All right, so when it says the possible rational zeros, that means P over Q. So let's see. For P, we need factors of 4. It's going to be plus or minus. What are the factors of 4? Right. For Q, plus or minus 1. Okay. P over Q, it's going to be each of these over 1. So you get 1 over 1, 1, 2 over 1, 4 over 1. You basically get the same numbers back. So these are the possible rational zeros. Okay, now look at this. Now we have to see, okay, fine. We found 6 possibilities. Let's actually find the actual zeros, right? Okay, so here's what we're going to do. We're going to use direct substitution or synthetic substitution to determine the zeros. So basically what you have to do is try each number to see which gives you 0. Okay, so we're going to do synthetic division with each one of them. You guys remember this from algebra? Yeah. Vaguely? Okay, so what you do is, what's the first number here? 1. You're going to take 1, put it in here, and see if that's going to give you a 0. All right, so here we have 1, -3, -2, 4. All right, so I'm putting the coefficients from here in here. What does that give you? 1, -2, -2, -4. And if I multiply, I get -4. If I add, what do you get? Oh my God, I got 0 the first time around. What does that mean? If you get 0, that means x equals 1 is a solution to this, okay? So we got 0, which means x equals 1 is a solution. Okay? So now, let me tell you how to work with that. So basically what we have, I'm just going to copy it down here because there isn't enough room over there. Okay. This one, right, gives you x minus 1. So basically what you do is you take that number and you do x minus that number. Okay? Now, in the very, very beginning, what was the degree of the function? 3. When you do synthetic division, the degree goes down by 1. So from x cubed, we're going to go down to x squared. And these are going to be the coefficients of a new function. So it's going to be from x cubed, go down to x squared. And here we're going to have x to the power of 2, x to the power of 1. And then what's x to the power of 0? That's just a 1. It goes away. And the last number we throw away. So basically what that turns into is 1x squared minus 2x plus 4. Okay? So basically we had x cubed and then x squared, x to the 1, and nothing.
Negative, oh, wait, should that be a -4?
Oh yes, I copied too quickly. So now if I copy that here, can I factor that? Can I? Because this is a 0, it stays with it here, right? Because the whole polynomial, that's part of the polynomial, and we're sort of factoring it little by little. Okay, so now this one, look at what it says. It says factor or use the quadratic formula to find the remaining zeros. All right, so can we factor this guy? Not possible, I don't think, but let's use the quadratic formula to find the other zeros. Okay, so how do you guys remember the quadratic formula? Right, that's the one. So negative b, which means negative negative 2, that's positive 2, plus or minus the square root of b squared minus 4 times a times negative 4 over 2a. So 2 plus or minus 4 plus 16 all over 2. 2 plus or minus root 20 all over 2. And then can we factor can we simplify the root 20? 2 plus or minus. So do you guys know how to simplify the roots? Okay, so if I have root 20, I do a factor tree for the 20. 20 is 4 times 5. If I can erase it. And then this is 2 times 2. Now, whichever one of these has a partner, it comes out. So a 2 comes out. And that poor little 5 doesn't have a partner. It stays in. All over 2. Right, so now, look, I have 3 terms here. If you can divide all 3 of them by the same number, you have to. So divide by 2, divide by 2, divide by 2. Next to it, you can. If it's inside the root, you can't. Okay? So this will be 1 plus or minus root 5. You should be able to cross out all of them or nothing at all. So basically, okay, so if you had like this, 3 plus or minus 2 root 7 over 2, right? Is there a number that you could divide all 3 of these by? No, then you leave it. But now, if it was like this, look, you have the 3, the 6, and the 2. If you can divide all 3 of them by the same number, then you must.
Wait, what do you mean? Wait, where's the 1?
Oh, no, you can't. I'm sorry. We'll make this a 3. Right? Now you can divide all 3 by 3, right?
And how
Then
that would be left as 1 plus or minus root 7?
2 root 7. So this would be 1 plus or minus 2 root 7. Okay? All right, so finally, what are the zeros of this function then here? Where are these zeros? This 1 is a 0. We're going to do a lot more of these tomorrow. 1 is a 0. And then this is a 0. So the zeros are 1 and then 1 plus or minus root 5. All right? You have to do that with the other ones. So we'll stop here and we'll continue from here. Do this next one, and we're just going to do it like, practically, boom, 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 get it done, and you'll see the steps, and it won't seem as bad. All right? So first and foremost, we have to find P over Q. Okay? All right. So the P, we're going to take it from the 15. So it's plus or minus all the factors of 15. So 1, not 2, but 3, not 4, 5 is 1. And then, just go up the numbers. 6, 7, 8, 9. What's another one? 15, right? So that's P. Q is plus or minus the factors of 2, which is just 1 and 2. So for P over Q, right, it's going to be the first row divided by 1, and then the first row divided by 2. So again, P over Q is plus or minus, and I open up a parenthesis. So it's the first row divided by 1, so you just get 1, 3, 5, and 15, correct? And then it's the first row divided by 2, so you get 1/2, 3 over 2, 5 over 2, 15 over 2. How many numbers are in this list now? 4, 8, 16 numbers. So essentially, here's what you have to do. You have to start with one of them, try synthetic division, and see if you get a 0. If you do, awesome. If you don't, move on to the next one. So sometimes, like we did here, you get lucky, and the first one you try gives you that 0. Sometimes it's the second one. Sometimes it's the 8th one. Sometimes it's the 14th one. That means you have to do synthetic division 14 times until you get the 0. Now, fun, I mean, listen, I could do it all day, okay? Time consuming, a little. So I'm going to give you, don't tell anybody, a way to sort of CHEAT. I'm not going to use the word, all right? We're going to cheat a little bit, okay? So here's what we're going to do. You're still going to show me all of the work, but the trial and error is what we're going to cut out, okay? So basically, we're looking for the zeros of this guy. Here's where your calculators are going to come in. Go ahead and take out your calculators, and you're going to graph that function f of x, okay? Okay, because my goal is for you to learn the process and then, skip the trial and error. All right? Okay, so here we go. We have got we have got 2x cubed minus 5x squared minus 28x plus 15. We're going to graph. Okay, now look. How many zeros do you see here? It looks like it's got 3 zeros, right? So what you're going to do is you're going to pick one of them. It doesn't matter which one you pick. It's completely up to you. Now look, when I pick, I make a smart decision and I pick a whole number. So you see how this 0 here is between the 0 and the 1? That's like a 2/3 or a 1/2 or something, right? I'm not going to pick that one. I'm going to pick a whole number like that one. 1, 2, 3, 4, 5. You see how x equals 5 here looks like it's a 0? That's the one I'm going to pick. So that's all I use this calculator for, just to visually see where there is a 0. Now, can you have picked -3? Absolutely. Whose decision is that? Yours, your decision. Just make sure you work with it correctly. All right, so we're going to pick x equals 5. All right, so I'm going to go with 5 here. So this is going to eliminate the trial and error, right? Here we're going to do 2, -5, -28, 45, 3, 2, 1, 0. 2 comes down. We multiply, you get 10. You add, you get 5. You multiply, you get 25. Huh? Oh, that's a 15. Phew, because I was getting nervous there. I'm like, that's not going to add up. Okay. -3, -15. Oh my God, how lucky are we? We got 0 on our first try. Okay? But like, if you had gone through the list here, if you had done like 1, 3, 5, right? It would have been the third one you tried. Or if you did +1, -1, +3, -3, -3 would have been the fourth one to work for you. Okay? All right. So now what we get is this. From here, we do x minus that number, okay, because we're factoring and then solving.
Why is it x minus 5?
It's always x minus that one. It's a number. This is the factor theorem, because if 5 is a 0, then x minus 5 is a factor. And I'll tell you why again right now. This, right, we started with an x cubed. Now we're going to go down to x squared. So it's 2x squared plus 5x minus 3. And you know what I'm going to do to make it better, because we're going to solve it, is set it equal to 0. Okay, a few little things here to, you know, some fun. This polynomial in the blue that we got from here, what is it called?
Quadratic.
Okay, it is a quadratic function, but if you get it off of your synthetic division, this is called a depressed polynomial. Right? You remember that? It's a depressed polynomial. Now, the task here is to solve it. So take a look. If you solve the red one, x minus 5, what does it give you? X equals what?
5.
X equals 5, right? Here. So that's why you do x minus 5. Now we need to solve this blue guy. Two choices. You either factor or you do quadratic formula. I always like factoring. So if you can factor, you factor. Let's try to factor. Okay, so you know the method where we multiply, right? Let's do that one. So you multiply the 2 to the 3. And I'm going to get, I'll do it in blue so it's color coded. So it's going to be x squared plus 5x minus 6. And then can we factor that? 6 and negative 1, good. So x plus 6, x minus 1 equals 0. And then from here, we still have the x minus 5.
And it would be 2x minus 1.
Right, exactly. Now, we took out a 2, so we have to bring the 2 back. Okay. Always keep that red x minus 5 along with it. And then this one we can divide by 2, right? So we get x plus 3, 2x minus 1 equal to 0. All right, let's get this guy up here. I'm just going to rewrite it. X minus 5, x plus 3, can you see? 2x minus 1 equals 0. Now, from here, what do I get? X equals 5. X equals negative 3. And here? Right, 2x equals 1. X equals 1/2. So these are the 3 zeros, and you're done. Do you see how if you do it quicker, it's actually not that bad? Like in the beginning, we just spent too much time, right? Now, you've already graphed this function, so you can just confirm on your calculator that, you know what, yeah, those really are the zeros that we got, right? We got x equals 5 here, x equals 1/2, and x equals negative 3, okay? And those are the 3 zeros. Isn't that cool? That's kind of cool. It's really not that bad, okay? All right. Now, there is a way to narrow down the search, right? Because, again, 16 possibilities. Oh my God, am I going to try each one? You could actually narrow it down and say, you know what? No. This function doesn't have any negative zeros. This function has 1 positive 0. You can narrow it down. The way to narrow it down is Descartes' rule of signs. I know you've heard of this one. Descartes, right? You guys know Descartes? He was a French mathematician, philosopher, huh? Last year you might have. You should have. Yeah. Descartes is the guy who said, I think, therefore I am. He was that French philosopher who said that. Okay, so here's Descartes' rule of signs. This is what Nadiv said looked scary. And yeah, that polynomial function looks fun and scary at the same time. But basically what Descartes' rule of signs says is it gives us information of the number of positive and negative real zeros. So it tells you this function can have 3 negative zeros and 1 positive. Okay? This function can have 1 positive and 2 imaginary. All right. So here's how we do it. Using Descartes' rule of signs, describe the possible real zeros of f of x. This is how it's going to ask you in the book. Describe the possible real zeros. So you're not going to use adjectives like, oh, they're pretty, they're cute, they're large, they're small. This is when it says describe, use Descartes' rule, right? Think about that, like describe, Descartes, same letters, okay? All right. So here's what we do. I know sometimes it looks scarier than it is. All right, here's what you do. For the number of positive ones, right? Go down the polynomial and see as you're going down, how many times do the coefficients alternate from negative to positive? So look at this one. It's positive 1 as a coefficient, then negative 3. So here, it flipped from positive to negative. So that's one time. And then it stays negative here, flips to positive, and then positive. So how many times did it flip? Twice. Now, the rule is, when you get that number, always subtract 2. Why? I don't know. When you run into him one day in the afterlife, you can ask him. We're just going to subtract 2, okay? If you subtract 2 from here, what do you get? 0. So you do 2 or 0. If you get 5 instead of the 2, what do? Subtract 2. What do you get? 5, and then you get 3, and then can you subtract 2 again? Yes, and you get 1. So you keep subtracting 2s until you can no longer subtract the 2. Okay. For the negative one, we need to take f of negative x. You know what you're going to do? I'm just going to give you the shortcut. Here's what you're going to do. The exponents, which are even, you're going to not touch them at all. So x to the 4 stays x to the 4. For the odd exponents, they're going to flip sign. So negative 3 becomes positive 3x cubed. X squared is even, stays. What happens to the positive 2 here? Comes negative 2 plus 7. So basically, whichever has an odd exponent, make it from positive to negative and vice versa. Now, we're going to do the same thing. How many times when you go down the list here, down the line, does the sign alternate? Okay, positive, positive. Here there is a shift. And then here there is a shift. So number negative 2 or 0. All right, I'll just do this and I'll let you go. So look, you're going to make a chart now. Positive, negative, imaginary. Okay? It's time. All right, I'll stop here.